Hi students. Now we are going to discuss about dispersion of white light by a glass prism. So this is the triangular section of a glass prism. AB is one refracting phase and AC is another refracting phase of the prism. And angle A is the refracting angle of the prism. Now what will happen when a ray of white light is incident on one of the refracting faces of the prism, namely AB? So white light is a combination of 7 colors. WIP-GR we have heard. So this white light is having 7 colors and hence it is a combination of 7 wavelength. As a result, white light is also called by the name polychromatic. Poly means many, chromo means color. So multicolor light. It is a combination of 7 wavelengths. So when a white light traveling in the air enters inside a glass prism, it will split into 7 colors. So the moment it enters inside the glass, all the 7 colors travel with different speed inside the glass. In air, all these 7 colors will travel together with the same velocity. But when the same white light will travel inside the glass means all the 7 colors will travel with different velocities because they have different wavelengths, and among all these 7 colors, the wavelength, the wavelength of violet, wavelength of violet color is denoted by the symbol lambda V. And this is the least 4 into 10 to the power of minus 7 meter. And the wavelength of red, that is denoted with the symbol lambda red, that is equal to 7 into 10 to the power of minus 7 meter. Now all the different colors between violet and red will undergo refraction at different angles, and once again they will emerge out of the glass prism and form a band of colors called as WIP-GR. Violet at the bottom, red at the top. The other colors indigo, blue, green, yellow and orange will be in between violet and red in the ascending order upwards. So this band of 7 colors only is called as the spectrum, visible spectrum. So visible spectrum is a band of 7 colors, WIP-GR we say, is it not? Students, now the emergent rays, 7 emergent rays are available. So you see that the incident light is traveling along the direction PQ and it is extended up to R. So PQR is the direction of the incident ray. With respect to the direction of the incident ray, we find that all these 7 colored rays have deviated from the original direction. You see that the red color light, so the angle between the incident ray PQR extended and the emergent ray corresponding to red color will give you the deviation for the red color. So by this angle DR, R for red, D for deviation. So DR represents the deviation for a red color. And you see violet color with respect to the initial, direction, you see that by this much angle it has undergone deviation. It has bent too much. It has deviated much. So the deviation for violet is denoted by dV. So we find that the deviation, deviation for violet, deviation for violet, that is D violet, is greater than the deviation for a red color. Understand? Angle of deviation is maximum for violet and minimum for a red color. And also inside the glass, the different wavelengths or the different colors will travel with different speed. Which color will travel with much speed, that only will have less deviation. One who is traveling slowly will be deviated much. So, which color should travel with the highest speed means inside glass, red color only will travel with the highest speed. So, speed, that is inside the glass, okay, inside glass, red, okay, or speed of red is maximum. I can write speed of red is maximum. So who should travel with the minimum speed inside glass? It must be violet. So inside glass, speed of violet will be minimum. So this happens only inside the glass. In air or free space or vacuum, all the colors will travel with almost the same speed only. Only inside the glass, this speed will be different. So the deviation is least for red and maximum for violet. Now, this is a glass prism which is splitting the white light into 7 colors. This phenomenon of splitting up of white light into its constituent colors, namely VIBGR, is only called as what? Dispersion. In our everyday life, there are so many occasions, okay? So when we take a plastic scale and look at the tube light, fluorescent tube light or a white light, some spectrum will be visible. That in the classroom sometimes you must have observed, is it not? Take a plastic scale and observe the tube light. So some band of 7 colors will be visible. Like that, have you come across a rainbow which is caused during the rain or immediately after the rainfall? So the cause of a rainbow is also due to dispersion of the sunlight. Now you can see that this is the demonstration of how a rainbow is being formed. Whenever you look at a rainbow, 7 colors, a rainbow in front of you, the position of the sun will be behind you. So from behind you, the sun's rays travel, it fall into the, or it enters into the water droplets which are arranged at a particular angle. A row of water droplets, rain droplets will be positioned in the atmosphere. And when the sun's rays enter at a particular angle, it undergoes first refraction, because sun's rays travel from air into raindrop which is water. So refraction will take place. As a result, it will bend, and then it will fall at the inner surface of the rain droplet and gets reflected. This is called internal reflection. That is the second phenomenon taking place after refraction. And then since dispersion also is taking place, it splits into 7 colors. So rainbow is caused due to the phenomena of refraction, internal reflection and dispersion together. So dispersion of the sunlight by the raindrops. So sun's position is behind the observer. Let us say that from the ground surface an observer is looking at a rainbow. Okay, one rain droplet for demo I have taken. So when the sun's rays, this is what? White light. The white light emitted by the sun, when it enters into the rain droplet, means what is going to happen? First refraction will take place, is it not? So I will show that refracted ray corresponding to red. So this is the refracted ray corresponding to red, and the refracted ray corresponding to violet, like this. I will show nearby. Okay, in between this red and violet, different colors will be there. Then from this end, from this point, in the interior of the raindrop, these two and all the colors in between also will be reflected internally. Is it not? This phenomenon, first phenomenon is taking place. One, this is due to refraction. This is due to refraction. Then internal reflection is taking place from here. Understand? So this is internal reflection, like this, internal reflection. So the red color also will be internally reflected like this. After that, when it is coming out, okay, after this it will be coming out. So that this is white light and red and this blue color, in between colors I have not shown, only the end colors. Is it right? Okay. So now it has to travel once again into the air, and let us say that here is the observer. So this is the observer's position. Okay, observer is standing here, and he is observing the rainbow. So the end rays I am going to show. So they will be falling at the observer's eye. So how do they reach the observer's eye? I will show you. So that the observer's eye here, first red is reaching here, and this violet, okay, this is a violet, it will be reaching here. So only the two extreme colors I have shown. This is a violet, and the other extreme color is red. Okay, this is red. These two colors, in between colors also will be visible. I have not shown, that's all. Okay, so this is how a rainbow is being observed by the person from the ground surface. Now here you can see that if suppose the person is standing on the ground, means the different colors will subtend different angles at the observer's eyes. Understand? Now you can see that this for violet, theta I will take as the angle for violet, and for red, is it greater than violet or not? The angle subtended by violet is lesser, and the angle subtended at the eye by the red color is more. So this is theta violet and this is theta red. So this for violet color it will be 41 degree, and for red color it will be 43 degree. So we are able to observe the rainbow. Okay students, what is the rainbow? Rainbow is a natural phenomenon of what? Dispersion of a white light. So dispersion of sunlight by the water droplets suspended in the atmosphere. Okay. Now when you observe a rainbow, the position of the sun will be behind you, and the rainbow will be in front of you. Okay students, and what are the three phenomena responsible for the formation of the rainbow? First phenomenon is what? Okay, we can write dispersion. Okay, mainly dispersion. In addition to that, refraction and internal reflection. So refraction and internal reflection. So these are the three different phenomena. Now whenever you see the rainbow, whenever you look at the rainbow, it will be bent only, is it not? It will be bent. It will be a part of a circle only. Part of a circle. Never you have seen a full circle. But actually rainbow is a full circle only. If you see from an elevated position like from a jet plane, the rainbow will be below you so that you can see the entire circle. But we are the observer on the surface of the earth, so we are unable to see the full circular rainbow. Anyhow, when you observe the rainbow from the ground surface, an arc of 7 colors is visible. Which color will be in the interior? The rainbow will be like this. So the interior color will be violet and the exterior color will be red. Understand? So in between, different colors will subtend different angles at the observer's eyes. So this phenomenon of splitting up of white light into its constituent 7 colors, which is only called as what? Refraction of dispersion of light. Understand? Due to refraction, it splits first and then it is coming out as 7 colors due to dispersion. Okay. Now inside the glass, the different colors are traveling with different speeds because of their different wavelength. So which color is traveling faster? That is red. Which color is traveling slower? That is violet. Okay. So now when the spectrum is formed outside the prism, you can see that the different colored lights have undergone different deviation. The deviation is not the same for all colors. So which color is undergoing the least deviation? That is red. And maximum deviation is observed in violet. And one more fact I am going to tell you. See, the refractive index of glass we have studied, is it not? Refractive index of glass must be a constant. It is a constant only for one given wavelength or one given color. For different colors, the same material glass will have different refractive indices. Understand? And a clue I will give you. When the deviation is less for red, then the refractive index of the glass for red will be less than the refractive index of glass for violet. This is because deviation for red is less than the deviation for violet. When the angle of deviation is less means then the refractive index of glass for that color will be less. Similarly, when the deviation is greater for violet means then the refractive index of glass also will be greater for violet, because these two are depending on each other, directly proportional to each other. Okay students, I hope you must have understood well. Fine.